Hello everybody, my name is Ben Brady and I am the 3D Printing Texan. This morning I figured I'd jump into DesignSpark Mechanical and see if we couldn't show people how to do something rather interesting. Yesterday was Father's Day and I spent most of the day just kind of laying around watching YouTube videos. And I happened to watch a video from Angus Deveson down there in Australia. Maker's Muse is his YouTube channel. Really good channel for 3D printing stuff. And he did a really interesting video about tops, spinning toy tops to make noise. And so I thought, well, that'd be an interesting project to do in terms of DesignSpark, so I could show people how to make a top in DesignSpark. So that's what we're going to do this morning. Now I've never made one, but basically it shouldn't be that difficult. And matter of fact, we may make a couple. One we may make solid or semi-solid, depending on the amount of infill that you decide to use. And we may try to make one that has some voids in it so that you can make it whistle. Okay, so, and there's a couple of interesting ways to do that in DesignSpark, so we're going to try that out. So let me go here and share the desktop and see if we can't get started. Now this is DesignSpark Mechanical. This is the startup page. We're going to go ahead and kill that, and so that gives us our blank space. So we're going to go here, File, New. We're going to create a new design. And the very first thing that I like to do when I'm in DesignSpark is, we down here we have a tab that says Design 2. And so what we're going to do is we are going to save this file as spinning top. Now the reason that we're going to do that is as we progress through our design, on a periodic basis, we are going to hit Control-S to save our work. Now, DesignSpark does have an automatic save feature, but in my experience, it doesn't seem to quite work well. I can show you how to get to it. If you go here to the DesignSpark options, and a window is going to come up. Let's see, it's not going to show up on our video because it's not part of the main DesignSpark window. So let's see if we can figure out how to pop that up. So I may have to create a different let's see here. Bear with me, because I really do want you to see this. And so we're going to create a new window capture, and we're going to create a new and this is called DesignSpark Options window. All right, so make the source visible, and there we go. Okay, so that's what we've got, and we'll go ahead and capture the cursor, and there. All right, so now you should be seeing in just a moment, there we go, the new DesignSpark window. All right. So let me go ahead and lock that in place. All right. So now what we've got here is we've got some options, and one of the options that we have is file options. And so we have some importing options, some exporting options, and let's see if we can find, there's an option here for automatically saving imported documents save imported data, and then use multi-threading and what have you. Let's see if we can find our automatic save. Let's see, is it in this window? Might not be. Advanced. There's the pull tool. Rendering quality, anti-aliasing. We'll find it here. Let's see. Selection. No. Snap units. Units, you want to make sure that you have units set to millimeters if you're going to do stuff with 3D printing. Navigation. I thought for sure it was under the file. Let's see. Pull. File options, and then we have general. And tolerance, is it further down? Here it is, under the support files. So there's an option here for backing up every X number of minutes. So if we turn that on, we can then choose how many numbers, and then we can keep the backup files for X number of days, and we can tell it where we want the backup. Now this puts the data in the app data folder under roaming, which is kind of weird, and then you can also clear the backup files if you need to. You can also browse for a different location, but it defaults to the roaming folder under app data. So it's username, app data, roaming, space claim, and then the file is, and then auto save is the folder. So, and then you can tell it to keep the backup file for 5 days. Now, what I have found is, for some reason, if things happen to these automatic backup files, things also happen to your main file. So I don't use this, I just do a Control S, but it's there if you decide you want to use it. There's been a number of issues there with that. Now let's see here, my window changed, so let's go back to what we were, and we can turn off the options window. So that's how you get to the options. You just go to the file menu and go to DesignSpark options, and that will open the options window. Now here in DesignSpark, because of the way my video setup is set up, you don't see, for whatever reason, you don't see the menu. So right now I have a window open. It's the menu window, the file menu, but my video capture card doesn't seem to be able to capture that part of the window. So I probably have something set up wrong, but I'm using Open Broadcast Studio to capture these screens. Okay, so let's get started. So the first thing that we have here is we have a sketch plane, and we're going to hit V to make the sketch plane present itself face forward. And we're going to start off with a sketch. And so the sketch is going to be for the top, not the top of the object, the top. So just, we're going to have a little bit of problem with nomenclature here, but that's okay. So what we're going to do is we're going to create a top that is, let's see, let's make a top that's 100 millimeters in diameter. So to do that, what we're going to do is we're going to draw some lines here. We're going to make a sketch, and we're going to go ahead and we're going to draw a line. So we're going to hit the L key for line, and we're going to start here in the center, and we're going to come out, and we're going to go 50 millimeters. And that's going to give us a line that's 50 millimeters long, just like that. Whoop. And we don't want to angle, so let's back that off a little bit and do this again. Line 50 millimeters, and then hit enter. Now we've frozen that line in place. Now we're going to do another line that is let's say 25 millimeters in the Y, and then I'm going to zoom out a little bit just to give us a little bit of working room. And then we're going to go, let's say, a 33-degree angle until we get back to our original line on the grid. So that is going to give us a top that has a point. All right, and then we're going to do a line down and create a closed subject. And then I'm gonna make a little construction line here at the top because we need that. And we need that for a particular reason. So we're gonna go there to the corner, and then that's it. So we have our shape, which is our lines. And so let me go ahead and select all the lines so we can see the shape. And we're there, and there, and there. So there's the shape of our top. And we'll fix it up a little bit here as we go along. And then we have our construction line here, which we're going to use as an axis. Now we're going to use that as an axis. So we're going to go P for pull, P on the keyboard for pull tool. And that's going to give us our solid shape. But we want to make this, we want to rotate this. So we're going to go P, and then we're going to say we want to rotate, and we're going to choose an axis to rotate about. So we're going to choose the construction line. And then rotate, it says rotate the face around the axis, select one or more faces to revolve, and then that's it. And then we're going to say right here, full pull, and that's going to rotate this shape around that construction line as the axis. So we're going to click on that, and there it goes. My computer's a little slow because it's a little old, but now we have a top, and as you can see, the top is cylindrical that comes to a point. And so that gives us our basic shape of the top, and it's fairly easy to do. A lot easier to do this way than in Fusion 360. It's very simple. You just draw the sketch and tell it to revolve around the axis, and you're done. So, Chico, be quiet. Hey. The dogs have no concept of video. So, anyhow, now the next thing we need to do is we need to create a hole for the spindle that you use to spin the top. So we're going to go here to the top, and we're going to go Control V, and we're going to bring that there to the center. And right now we have our construction line is still there, so we're going to go ahead and select that. If we can get a hold of it, like so. And will it let us get it? Let's see. We have to be able to select it. So let's see here. It doesn't seem to want to let us get it. So let's see here. If we change planes, There it is. Okay, so now we can select it and we can delete it. All right, so now that's gone. So now let's go ahead and change planes again. Just click down on the bottom and then we can pick that up. Now we have our plane that we want, so we're going to use that. And we're just going to zoom in a little bit, and we are going to create a hole for our spindle to go in. So we're going to C for circle, and we're going to go to the center, and we want a spindle that is, say, 6 millimeters. 6 millimeters in diameter for the spindle. Actually, what we want is, we're actually going to do this a little bit bigger. We want to say 6.1 millimeters. Now, the reason we want the 0.1 is this is going to be a press fit for the spindle. And so if we create a spindle that's 6 millimeters, it probably won't go in there. And I know that my printer, the tolerance that my printer prints, if I'm in a circle and I go to 0.25, then that will actually. So let's do this. I want to do 6.2. I want to make this just a little snug. And so it's going to be a press fit. So we're going to go ahead and get out of that mode. Hit D to get back to three-dimensional mode. And then we're going to go ahead and we're going to push this down into the shape, let's say 10 millimeters. So that gives us a hole 10 millimeters deep and 6.2 millimeters in diameter. All right, now that gives us one hole. Now let's say I'm going to go ahead and I'm going to copy this object like so. So I selected it with the select tool and did a Control C, and then I'm going to paste, and then I'm going to go to the move tool in the menu in the ribbon and come up with a move, and I'm going to just move this over by 150 millimeters, just to give us some space to work with. So now we have two tops. Now, one of the interesting things that we can do is we can make this top hollow. And there's an interesting way to do this. This top is an enclosed object, and there's an interesting aspect in the shell command in DesignSpark. Now, for example, if I take, just for the heck of it, if I go here to a sketch plane, and let's say I do a rectangle, R for rectangle, and I create a rectangle that is, say, 100 millimeters square. And I go back here and I pull that up 100 millimeters. So now we have a 100 millimeter square cube. Now, I can actually create this cube as a hollow cube where there's nothing inside it. And how you do that is you go over here to the component list and you select the component and you highlight the whole thing, and then you go to the shell option up here on the ribbon, and then it's asking you, okay, how thick do you want the wall? That's what this 1 millimeter it defaults to 1 millimeter. So so let's just say 2 millimeters. And when we do that and we complete the shell with the check mark, what we have now is we actually have a hollow box that, and you can see here, it's a little crooked, so let's see if we can figure out how to move it around. So let's go ahead and select it, and So here we have a cube, and let's create a plane, and it's creating a plane for the whole sketch here, as you can see. So, but we want to create the plane so we can split the cube. So let's, we have the plane there, let's move the plane and go here, and now we can, I got to be careful here because I don't want to cut my I don't want to cut my tops. So let's see if we can move the plane over. No, doesn't like that. See, it's going to cut right through the tops. So let's let me do this. I'm gonna kill that plane, and I'm gonna move the cube. Got to select the whole thing to move the whole thing there, and then I'm going to create a plane on the face of the cube. That way we can avoid our tops, and then we can move the plane back into the cube. And now if we come into the plane and we tell the plane to split the body, so we want to split that body, and we want to use the plane to cut the body. So now that creates a cut in the cube. And so now we have solid 1 and solid 2 here. So if we say solid 1 and we tell solid 1 to move, solid 1 to move, we're going to move it out, and you can see here that there's actually a shell with a 2mm wall. So if we go here and here and we tell it, so here we have 2mm. Okay, so that's how you create a hollow shape. Now, so you can do that. So let's go ahead and back out. And we'll get back to our tops. So now, here we have our solid top over here, and this is the top we're going to use to make a shell. So if we select this, so we're going to say, we're going to call this, we're going to rename these objects here so we can keep track of them. This one is solid top, and this one is hollow top. All right, so this one is the hollow top, so we're going to shell this one, and we're going to tell it we want this one to be 2mm, and so now what we've done is we have created a hollow top with a 2mm shell, including inside of the hole. Okay, so this hole is 10mm deep, and then 2mm below and around this hole is empty space. Okay, so that's pretty much how that works. So I'm going to go ahead and hit home, and then we're going to go ahead and rotate this around. Now, what I'm going to do is I'm going to cut some holes in here, and see if we can't make something that can make a sound. So because we're dealing with cylinders, it's a lot easier to deal with the sketch planes. So if you go K, V, and you select the top, then you can change the plane to a particular surface. So in this case, what we want to do is we want to change the plane to, because we want to sketch on the side here. So let's see if we can't select a surface to, maybe we're not going to be able to do that. Let's see. So we have our cylinder, KV. There we go. All right, so now I believe we're probably, yeah, we're on the surface. All right, so that's what we want. And so what we're going to do is we're going to we're going to put a rectangle 10 millimeters square in that surface, and now we can use that to punch a hole, and we're going to punch a hole all the way through. All the way through. Oop, we ended up punching a hole. Let's go ahead and back up a little bit. And we're going to lower our rectangle slightly so that we can miss our center point. So we're going to draw the rectangle there, tilt it up slightly, and go through all the way. And so now you can see inside of the top there is our hole, and if we spin it around you can see it comes out the other side. All right, and so these are going to be our, actually we need to center these, so let's figure out how to center them because they're not quite centered. So let's see, and part of the reason is our sketch plane is not centered. So all right, so now there it is, it's centered, we're looking straight on, and then we're going to go ahead and we're going to say 1, 2, 3, 4, 5, and we're going to draw a rectangle that's 10 by 5. And let's see, I think I probably goofed that up, so let's bring that out 1 and bring that in 1. So now we're right on the center, 10 millimeters on our sketch plane. Go here and then go here, and then we can push it through. And you can see there's a little bit of offset here, and that has to do with the curvature of the shape of the top and in relation to the sketch plane. So let's go ahead and tell it to pull, and we're going to pull that all the way through. Just make sure we get all the way through. We haven't hit the bottom, and there's our on the other side, our hole on the other side. Okay, so now what we want to do is we want to make a little chamfer to make this whistle as it spins. Now we don't know which direction it's going to spin yet, so we want to just catch both of these edges. So we're going to highlight this edge, and we're going to highlight, scroll out a little bit, turn this way, scroll back in this way, and hold down the control key, and now we have both edges selected. Now we're going to zoom out, and we're going to flip this over so we can get at the other side, because it's the easiest way to do that. It's just flip it over 180 degrees, and then we're going to zoom in. We're going to catch this edge, hold the control key, and then we're going to rotate it a little bit, and then pan, hold down the shift and use the scroll wheel, let's see, am I lost? I don't want to hit home because that'll change my orientation, and what I want is this edge that's back here. So now let's go back in here, and then we can zoom in and hold the control key and hit this edge. Now we have all of our edges selected. So now we're going to zoom out a little bit, and we're going to rotate this 180 degrees again to get back to our starting point, because here in DesignSpark we have to do our move from the starting point. So whatever direction of the arrow is, and I'm going to rotate this just a little bit so you can see what's going on. So now what we're going to do is we're going to create a chamfer. So we're going to select chamfer, and then we're going to chamfer these 4 edges. So we're going to go ahead and bring them down to let's say 1.75. So that's going to give us a little bit of an edge right there. Okay, so it narrowed the wall just a little bit, just enough to make things whistle a little bit. And so at this point we now have a hollow top and a solid top, and it's time to create our spindles. So now I'm going to hit the home key, and I'm going to reset the home view because I don't want to have to keep moving things around. Let's see, we're going to go here, and then we're going to go here, and sometimes getting things navigated is just a little interesting. Now we're going to go up here to the home button, and there's a little down arrow by the home button on the ribbon. If you click on that, it says set as home view. So set that as home view. Now this is home. So if I go like this and I say hit home, it's going to pop over here, and this is going to be our view. All right, now we have a hole in our top that is 6.2 for the diameter, 3.1 for the radius. And so now what we want to do is we want to create a spindle, and the spindle is going to print. It's not the reason we're creating the hole to push the spindle into is we're going to print the spindle in a different orientation than the top to give the spindle some strength, because to spin these tops you got to wind them with spring and then pull on the string, and that pulling motion exerts a little bit of force, and if we were to print the spindle in the same orientation as the top, then it would break the spindle at the layers. So we don't want to do that. We want to print the spindle laying down. And so that's what we're going to do. Now, to create the spindle, the easiest way to create the spindle is to just create a cylinder. So we selected the cylinder tool, and we're going to hit K, V, and we're going to select the top here, and we're going to draw a cylinder, and we're going to make the cylinder 6 millimeters. And we're going to make the cylinder let's try that again. We're going to make the cylinder 60 millimeters long and 6 millimeters in diameter. So that's what we got there. All right, so now if we hit D, there's our spindle. It's 60 millimeters long by 6 millimeters in diameter. Okay, so now that'll fit in the hole. That'll just press fit into the hole. Now we could have made it longer, and then we probably should make it longer. So let's go ahead and we're going to grab the pull tool here, and let's go ahead and add another 40 millimeters just for the heck of it. So now we have here's our cylinder, and it is now 100 millimeters long. All right, so that's our top. Now, all we have to do is print that, stick the cylinder in there, and then, but then we have to have a launcher. Now, the launcher is kind of an interesting construct because we have to have a handle and a place to put the spindle into, and a way to wind the string around the spindle. So let's do this. Let's go ahead and get back to a sketch plane, and we're going to create a launcher. So let me rename the spindle here. Spindle. And let's create a launcher. Now, creating the launcher is going to be interesting because we just have to figure out how it's going to look. So let's, we need something that we can hold in our hand, and it's kind of going to look like, it's kind of look like a slingshot in a way. So let's see. Let's go ahead and do this. So we're going to start off with some basic shapes. So we're going to go R for rectangle, and we're going to go. We're going to create a rectangle. Now we have to have a rectangle that's going to be at least 50 millimeters deep, because we have a 100 millimeter top. So let's go ahead and create, let's say it's going to be 60 millimeters deep. Actually, we're going to need more than that. So let's say 80 millimeters deep. And we want it to be probably going to want it to be somewhere in the neighborhood of 50 millimeters thick, because we have to put a hole in it, like so. So here we are. So let me fix this because I didn't. So there's 80. By 60. Okay, so that's going to give us that. Now we want to put a hole in it, and we know that the top is going to be 50 millimeters from the center where the spindle is to the outside edge. So we have to be careful. We don't have a whole lot to work with here, so we're going to go circle, and let's just scroll in a little bit so we can see our. And we're going to go. I'm going to go ahead and move the grid just so we can be a little bit more accurate. When in doubt, just go ahead and move your grids. There's nothing that says you can't move the grid to make things easier for yourself. So now we have a square that is 80 millimeters by 60 millimeters. So if we put, and then, matter of fact, let's move our grid a little bit more so that we have like that. So now we have our center right there. Now we can use our centering. If we go here, oops, sorry. Now we have our centering here. You see where it calculates the center. So now if we go in by 20 on the 80, we still have another 10 clearance, and so we can create a hole. So let's do a circle. Right here, 20 in, and we're going to call this circle, we're going to give it a little bit of room here. So we're going to call this circle 7 millimeters. It's going to give us a little bit of play so that we can stick the spindle into it. Okay? And we're going to go here. And now we have a spindle that's 100 millimeters long, and so we want to account for that. So what we're going to do is we're going to create our block using the pull tool of let's say 80 millimeters. That gives us a little bit of play. So 80, and you'll see what we're getting at here now. So what we have a block with a hole in it, 7 millimeters hole. And now we're going to go ahead and we're going to use this edge, and we're going to cut a shape out of it. So we want to use a shape. We're going to use another rectangle, and we're going to go here at the 20 millimeter mark. So these are going to be 20 millimeters thick. And we need to leave a little bit of room for the top, so we're going to go in 65 and down to 40, and that's going to give us room for the spindle, because the top is going to be below this edge here, and so that's going to give us that. So now let's go ahead and go back to our three-dimensional shape and use the pull tool and cut through there. So now we have a place here where the spindle will come up through this hole, and we can wind our string around it. Okay, and then we need another shape for our handle. So let's just go ahead and create a handle. And we're going to create the handle, let's see, let's create a handle that's like 120 millimeters. So we're going to go up here and do an R for rectangle, draw a rectangle, 120 millimeters long. And then we're going to tell it to be, let's see, 40 millimeters high. So that should be plenty. Oh, we didn't set the 120. And so now we've got a handle that we're going to go here. We're going to say up to, and we're going to say to this edge. So that's going to give us that. And let's go ahead and round these edges a little bit to give it a little bit more body. So we're going to grab that edge, and we're going to grab that edge, and we're going to tell it, oops, I missed with the control key. Control, oops, I missed again. Sometimes it's a little tricky to grab these edges. What's going on here? Is it not letting me grab the edge? Yeah, all right, so let's just do it this way. So I'm just going to go ahead and round it all the way out. So we're going to say 20 millimeters. Give it a 20 millimeter radius. And we're going to do the same thing for the other side. So there's our, and we could do the same thing for the ends. Well, I don't know why it's not behaving today, but let's go ahead and say 10 for this end, and just do something weird there. We're not getting an arrow. All right, so let's back out. So we've got that edge. Rounded corner. 10. We're going to come down to the bottom side, grab that, rounded corner 10. All right, so now that gives us our handle that we can use for the top. And we might want to round the inside edges as well here. So let's say this one, let's see, can we grab that other edge? Let me move this up here. Yeah, let's just do it that time. Strange. All right. And then we're going to go ahead and we're going to round these edges. And we're going to say 10. Like so. So that gives us, you know, a reasonable handle. Something that's fairly easy to print. All right, so now we've got all of our pieces here. What we have to do is print them. So that's how you create a top with a spindle and a handle in DesignSpark Mechanical. Very straightforward. Let me hit home so we can zoom out a little bit. And so we have a hollow top, and we have a solid top, and we'll print a couple of spindles laying down on a raft, because you're going to need a raft or a brim to hold those. And then of course we have our launcher. So let me jump back here to this shot. So that gives you an idea of some of the things that you can do very easily in DesignSpark. I figured, what the heck, we might as well just jump in here. Thanks so much to Angus Deveson and his Maker's Muse channel. You learn a lot from that channel. He's a really interesting guy. He knows a lot. He knows his stuff. He's a young kid, but he's really, really sharp. So check him out. That channel is called Maker's Muse. And we're glad to give him a shout out, because he's really helped me learn a bunch of stuff for sure. But DesignSpark is real easy to do this. You can do it in Fusion 360. You can do it in any number of tools. But I think DesignSpark is by far the easiest way to do this. So I am Ben E. Brady, the 3D Printing Texan. Have a great day, and God bless.